This is core pure paper 1 from 2019 for the Further Maths Edexcel thing. It's these two books here. Let's go straight into it. I will say beforehand, I'm not very well, so I think that's probably going to come through pretty easily. So we've got two roots here. Obviously the other two roots are just the complex conjugates, so we just flip those two signs around. And then I honestly don't know what you're getting 4 marks for here. I'm really confused because I'm pretty sure I can plot points on a graph. This probably wouldn't get you 4 marks. In fact, I know it won't because I'm going to put the entire mark scheme next to it. What it wanted you to maybe do, real, imaginary, then it wanted some coordinate points here. When you read the notes, it says that you need to have some indication that it's about complex numbers. So I guess that's what this does. Or you could write this as 3 plus 1i or whatever. You don't need arrows anywhere, but just don't be so lazy that you don't pick up all 4 marks there. Otherwise, it's obviously a ridiculously easy question. Now, there's a few ways to do this next bit where you're finding A, B, C, and D. Obviously, the first thing I thought was just the roots of polynomial stuff. So multiply all 4 roots together, and you get this over this, but this is just 1, so that's just D. It's of course positive because there are 4 of these. If there's an even number of roots together, that makes this positive. Now you can just multiply this in a calculator if you want to, otherwise you can do it by hand, but otherwise you get D is 50. I think you get that these two multiply to make 5 and these two multiply to make 10. Then you look for the sums of the triple products. So pick any 3 and add them all up. So pick those 3 roots first, then those 3, I just swapped this one out for its pair, then pick those 3 where I took out that one, and then pick those 3 where I took out that one. And they all multiply to make minus, because there's 3 of them each time, c over 1. Now, you can multiply all these together. Again, you could just put that into a calculator and multiply it, and you'll immediately get the answer. Or you can, I did a bit of effort there to get that, but whatever. And then the sum of the pairs, there are quite a few pairs to do. Make sure you don't miss any. Again, you can just put it in the calculator if you want to, but eventually you're going to end up with, I did it largely by hand just because I didn't have anything else to do today. I'm ill and I can't really go anywhere. B is 3, and then eventually you can do just the sums of them, of the 4 roots, make minus a, and that's very easy to do, and you get your answers. Probably not the easiest thing to do there, but I mean, you can just type all this into a calculator, so it is actually pretty easy. The other way to do it is just put all 4 roots into the factored form of this polynomial here, so z minus the first root, z minus the second, third, and fourth. Then if you expand those 2 brackets out, you end up with a lovely quadratic. And if you expand those 2 out, you of course end up with a nice quadratic. You can check that the roots of this are those 2 and the roots of this are those 2 to make sure you got it right. And then of course if you were to just expand this out, it should match perfectly with this. So you just expand this out and you're going to get some coefficients that you can match, and you'll be fine. You'll get all the answers that I got before. Good. Question number 2. As soon as you see something with a product on the bottom, you should immediately think partial fractions. So that's what I did. Of course, remember when you've got a quadratic on the bottom of one of them, you need a linear term above it. So that's the only thing that I think can go wrong here if you're just not doing this whilst thinking hard enough, but you need a linear term here if there's a quadratic here. Of course, you can times that across there, and then compare with the 8x minus 12. Probably the easiest thing to do here is to set x to be minus 1 to start, because then you can just clear out this, and putting in minus 1 gets you 5 there, and minus 20, sorry, yeah, because minus 8, minus 12, minus 20. Divide by 5, you get c is minus 4. So that's good, we can put that in there, and then we got to sort out some way of finding a and b. There are lots of ways to do this. If you set x to be 0, then I think that's quite a good one to do, because what of course happens is you get rid of this a term, so this bracket just becomes b, so then you can solve for b. This of course is just numbers, and you solve for b and you get this. And then probably the easiest thing to do now is just to say, well, okay, over here you've got 0x squareds, and over here you've got ax squareds minus 8x squareds. So 0 equals a minus 8, and so a is 8. And we'll have our three things, and we'll split this up into this thing here. Now, of course, we can just integrate this thing and this thing separately. Now, they both integrate to logs because you've got the form f dashed over f in both of them. This, of course, is just 4 log of x plus 1. But this one, if I were to derive this bottom bit, I'd get 4x. But I've got 8x on the top, so if I just times that by 2, I think I've got the correct thing. So derive this here, derive log of 2x squared plus 3, you put that on the bottom, and you derive that for 4x times by 2, and you get 8x. Of course, this is much the same. And now, okay, what I decided to do is just take out a 2 here, to make it look like this. And now I can bring that 2 to the top here to make that. And now I can use log laws to say it's log of this divided by this. with the square. And I'm evaluating that between infinity and 0. So okay, that's fine, because if I put infinity in, I'm going to get 2 lots of this thing squared, infinity squared I guess, over infinity squared, but that's just limits to 2. So you just think, what's the limit of that as x goes into infinity? And it is essentially just 2x squared over x squared, which is just essentially 2, and so it's just log 2. And then when you put in 0, you get log 3 over 1, I believe, so that's just log 3. And then you can use log laws again, this is log of 2/3. And then finally, bring that 2 back up to the top. 2 squared over 3 squared is 4 over 9, and we'll have our answer. Excellent. So a nice little polar coordinates question here. We've got this sort of table here that's had this curve cut out of it. Eventually we're going to be looking for the area of this shaded bit here. So okay, show that A is 0.2. Well, if this is 1.2, then this bit here is 0.6. So that's fine. That means that when theta is 0, like when you're running between 0 and 2 pi, theta is 0 is here, and then it runs this way, so this here is pi over 2, then this here is pi. You're kind of rotating around, making this thing here, and then 3 pi over 2, and then 2 pi. So when theta is 0, or when theta is 2 pi, we have that r is 0.6. But of course, when theta is 0, cos of 0 is 1, and so you get 0.4 plus a, and so a is 0.2. So that's nice and quick to show. If AD is 60 centimeters, now just notice the trick here. 60 centimeters is 0.6. We're being asked for meters squared as our answer, so let's put it all in meters. So okay, well the area of the rectangle is just 1.2 times 0.6. And our idea is just to work out the area of the rectangle and then take away the curve. So the rectangle is just that, which is this. Now the curve is, when you're doing integration of polar coordinates, there's that formula, isn't there? The half integral of r squared is the formula you need to use. So we need to do half integral of this squared between 0 and 2 pi to get ourselves all the way around here. Of course, you could just integrate between 0 and pi and then double it, which will cancel that half, which is quite a sensible thing to do. But of course I didn't do that. I just did this. I put the 0.272 minus in front. I mean, this is just going to be the answer when I eventually figure out what that is. Of course, you can expand out this, and that's why I've got rid of all this, because all I really care about is this maths now. You can expand out this this binomial here to get this. At this point, you want to get rid of this because you can integrate that easily. You can integrate that easily. This, not so much. So from the formula book, you have your compound angle rules. You can set a to be equal to b, and then you get cos of 2 theta, and then you can rearrange, and you eventually get this, I believe. So I'm going to, and then I've got cos squared of 2 theta. So just replace that with 2 theta, which replaces this with a 4 theta, and then we have something integrable like this, and then we do this, just halving both of those things there. And then we can combine that with that to get this. And I've also integrated at the same time, it seems. So this combines to make 0.18, which integrates to 0.18 theta. Cos integrates to sine, but of course there's going to be a half there because of that too. And then again, this integrates to sine, but then I have to divide this by 4. And so that's good. So I have this, and then this actually ends up being quite easy because when you put in 2 theta, that goes away because sine of 4 theta is 0. That also goes away. When you put in 0, this goes away because sine of 0 is 0, and so does this. So, and also when you put in 0 into that, that goes away. So this whole thing is literally just 0.818 times 2 pi, which is 0.36 pi. Times by half is 0.18 pi again. And that's the answer, which in a calculator looks a bit like that. So good, not too bad a question. We're getting through this nicely. Question number 4. This initially looks like it could be a proof by induction. It usually says if it's a proof by induction though. And also, you might have wanted to have a quick look through the paper before you start a paper like this. And there's a clearly written proof by induction in like 2 questions time. So this is not an induction proof. They wouldn't ask you to do that twice in the same paper. So okay, what is it then? Also, you can tell it's not induction proof by if you try to do some induction, say, okay, we'll let n equal 1 or whatever. You can't show it's this thing because you don't know what a and b and c are, so it's a non-starter anyway. So okay, how do we do this? Well, surprisingly, you'd have to use partial fractions again, right? It's surprising that they've asked you to do that twice in 3 questions, but it's an important thing in math, so I guess that's why. So let's partial fraction it. We'll do this. We've seen partial fractions before today, so I won't go over it in any great detail. I think I did this in a vaguely efficient way, but I'm not 100% sure. I just set out to be some things that eliminated 2 of the variables and kept 1 of them, and I got the answers fairly quickly. And so we have this as our thing to consider now. So I'm just going to start considering this. Now, what I'm hoping happens is, because of this negative here, what I'm hoping happens is when you start putting in some values, you get some cancelling. So I just wrote out what a bunch of the first few terms were, and then tried to spot some easy cancelling that could be done. And hopefully, I was just hoping to maybe have a couple at the start and a couple at the end, and that would go together like this. And then I'd be very happy. Unfortunately, I couldn't spot anything. So I actually expanded out some numbers, and I still couldn't spot anything. And I was feeling a bit down on myself at this point. So what I decided to do was, okay, maybe it's just a really hard spot. Like, there must be something in here, otherwise you have no hope of getting this. So what I decided to do was just write it in a slightly different way, I sort of knew to do this because I've seen this sort of thing before, but I decided to write it vertically. So r equals 0 gives you these three terms, just those three there. Then r equals 1 gives you those three terms, and so on, until you get here and there. And what you can maybe see now that I've written it like this, is that you've got a plus sixth and a plus sixth. Now, I was annoyed when I was up here because I thought the sixth and the sixth would cancel. Like, I was annoyed that they were both pluses and didn't just cancel for me. But when I wrote it like this, I could see why. It's because 1/6 plus 1/6 is 2/6, which is 1/3. And then they can cancel with this minus a third. And likewise, 1/8 and 1/8 can add to make a quarter, which can cancel with the minus quarter. So actually we have this really interesting cancelling where we're going to cancel terms sort of down and across like this. And then likewise this next one will be 2 more than this one, so that's going to be a 10th, which adds to that 10th to cancel with that 1/5. And so we're just going to keep doing this. And what we're going to end up with eventually is we're going to end up with these three terms not cancelling with anything, because they're too early to start this sort of diagonal cancelling, and these three last terms not cancelling, because that one will go away with the 2 above it, and these two will go away with the 1 above it, but these three won't cancel either. So you've got these two triangles left over, the first three up here and the last three down there, and those are the only terms you have left over. So a really interesting bit of cancelling there. That's not an easy spot. I thought this question would be much easier than it was when I first saw it. But of course these things also go away, right? So you're just left half minus half is 0. So you're just left with this. And then it's just a case of what's the easiest way of putting these things together. I decided to double both of these terms. Just this middle term. I decided to double just to make them all 2's. And what that meant I could do was, of course, these terms can just go together very easily because they have the same denominator. And so that just becomes this. And then I think I doubled both these to give them both 4's. I did, yeah. So now we've all got 4's on the bottom. Now I can just times this one by n plus 2, n plus 3 over itself. This one just needs an extra n plus 3, and this one needs an extra n plus 2. And I think everything now matches. That was kind of the gradual way that I did it. Now I can just put all the numerators together under the same denominator. I can do a bunch of expanding out. I pray that whatever I get factorizes, and it does. And so I think I'm pretty confident that that's the right answer once I've got there. Good. Question number 5 is a differential equations question. You've got, it's one of these ones where you have to, I don't like these at all, I'm not very good at them. You have to read a bunch of information and then form a differential equation out of it. I think this is just practice, and I don't practice this enough. And so that's why I'm not very good at it, just because I can't be bothered to do this kind of thing in my spare time. So you've got a tank capacity 250, tank initially contains this much water. You're gaining 3 litres per minute, and the outflow loses 2 litres per minute. So what I can read from that is that we start at 100 litres, and at time t, we have 100 plus t litres, because every minute we gain 1 litre, because 3 litres enter and only 2 leave. So we gain 1 litre every minute, so at time t there are 100 plus t litres in the tank. Now we can also talk about the concentration of salt. The concentration, the grams they've given us as salt is S. So if I divide that by the total litres in the tank at any time, that's the concentration of salt, like the grams divided by litres. So the concentration of salt at any one time is S over 100 plus T. That's grams per litre, that's the concentration of salt. The amount of salt divided by the total volume in the tank. Now, of course, if 2 litres are leaving per minute, the amount of salt leaving per minute is this times by 2. If I times this by 2 litres, the litres cancel, and I just get 2s over 100 plus t grams is the amount of salt leaving every minute. But of course, each litre of salt contains 1 gram, and 3 litres enter means 3 grams of salt enter per minute. And so this ds by dt, and remember ds by dt is rate of change of amount of s per time. The rate of change is the amount that enters take away the amount that leaves. So 3 take away this, which will give us our differential equation here. So that's the very gradual way of building up that thing there. Okay, part B. Find the number of grams of salt in the tank after 10 minutes. So okay, well what we have to do is obviously we take our differential equation and we need to, I can't even remember what we need to do. Oh, of course we need to, let's put this thing over on the other side. And hopefully we recognize this sort of equation here. It's not separable. The first thing you look for is, can you just separate the variables and integrate? And it's very hard to. So the next thing you do on your checklist is you think integrating factor. Is there a way that I can multiply this to make it into something that would then be a product rule differential backwards? So okay, integrating factor integrates, times it by e to the power integral of 2 over 100 plus t. Because the function attached to s is 2 over 100 plus t. Now, of course, this integrates to just a 2 log of 100 plus t, but this 2 can bounce up to here to make 100 plus t squared, and then the e can cancel with the log to just give you 100 plus t squared. Okay, so let's multiply this entire thing by this thing here. And we get this. Obviously, one of them cancels here, and you just go left with one left over, then that has a squared there. And what you can notice about this is this still doesn't look friendly to integrate at all, but the whole point of an integrating factor is it gives you something that's that is the result of having done a product rule, differential. And we can see that because if we just try and differentiate this thing here with respect to t, differential of s with respect to t is ds by dt, leave this one alone. And then differential of this is just 2, this differentiates to 1, so just this to the power 1, which gives you this. So that was the point of the integrating factor, to help me get this, and now I can just integrate both sides to cancel this d by dt and integrate that one. Leave this thing alone, obviously, because you're just cancelling there. This integrates very easily, because of this 3, it actually just straight up becomes this. And then I can just work out what the plus c is, I think, by saying at t is 0, the amount of salt in the thing is 0, because you haven't put anything in yet. And so 0 over here, because 0 times anything is 0, equals 100 cubed plus c, so c is minus 100 cubed. And that's going to be my solution. Well, that's going to be a general solution, and then I need to work out the amount of salt after 10 minutes, so I just need to shove t as 10 into here. So I get some number over here, of course, and then I divide by 110 squared, and I'll get s as this number, apparently. So that's good. When the concentration in the tank reaches that, the valve is closed. Okay, so when the salt concentration becomes too high, the valve is closed. Now, I obviously can't just put in, so 0.9 grams per litre is the concentration of salt. It's not the amount of salt. So the 0.9 doesn't go here and you solve a t, because then you're asking when are there 0.9 grams of salt in the thing. You're asking when there's 0.9 grams per litre. But remember earlier, I defined what the concentration of salt looked like. It was S over 100 plus T. That was what I defined earlier, the grams of salt divided by the total volume, which is going to be this at time t. So what I can do is, if I look at this equation here, can I make this? Well, yeah, if I divide all of this by 100 plus t cubed to get this, of course that all cancels to make a 1, and this becomes this makes 10 this. This is the concentration of salt, as I defined earlier. So this is now actually 0.9. And now I can solve this for t to find the time in which this happens. Obviously, this makes this 0.1. Does that make that 0.1? What am I doing? Yeah, it does. 1 minus 0.1 is 0.9. Good. 100 cubed divided by 0.1 is that. Equals this. Cube root it. Take away 100. Type that into a calculator. And you get 115 minutes. Evaluate the model. Now, I actually assumed that this would be after 150. Because, of course, when time is 150... you overflow the capacity of the tank because you add a litre per minute. And so at time 150 you'd overflow this thing. I assumed that would be what happened, but it doesn't, so all we have to write here is this whole thing that they said at the start here of salt, it mixes instantly with the contents of the water. It's not going to mix instantly, and it's also not going to mix uniformly, right? The salt is going to dissolve into the bit that it's just entered, and the rest of the tank is going to be pure water still. Like, it's not going to just dissolve across the entire water in the tank immediately. It's completely ridiculous. But anyway, so yeah, just write something like that and you'll be fine. So this is the proof by induction question then. It's actually, I thought, a super nice one. Literally, as long as you know how induction works, this shouldn't be too bad. Let n equal 1 be first. There's positive integers n, so we might as well start at 1. If n equals 1, you get this. You can type that into a calculator, can't you? You get this, which you get this, which is obviously divisible by 5. Maybe you want to write it's 5 times this, but just to be super clear, but it's obviously divisible by 5. Ends in a 5. Okay, so now we just assume that it's true for n equals k, so we assume that this thing is divisible by 5. That's our assumption step. And then we say, okay, well, let's n be k plus 1. And we put k plus 1 into here. Now, if you put k plus 1 into there, you get 2 brackets k plus 1, which is 2n, or 2k plus 2 plus 4, which is plus 6, and same here. And now what we can do here is, whenever you're doing proof of induction, you're desperate to get this. Like, you want this, because you want to use the assumption step. So here, I can say, well, this is 2k plus 4 plus 2, which I can write as 3 squared like this, because when you add the indices when you multiply things with the same base. But this is, of course, and I can do the same thing here, this is, of course, 9, and this is, of course, 4. So I end up with this. And again, I'm desperate to use the assumption step. So what I'm going to do is I'm going to break that out into 5 of them plus 4 of them. And now I can factorize this to be 4 of this minus that. Like this. Oh, sorry, like this. And now by assumption step, that is divisible by 5. From the assumption step, that's what I said before. But also, this is clearly divisible by 5 because it has a 5 in it. And so f of k plus 1 is a multiple of 5 plus another multiple of 5 by the assumption step, and so is divisible by 5. But if it's true for n equals 1, and if it's true, you just say this stuff always at the end, do you? If it's true for n equals 1, and you can find some, and you've shown that if it's ever true for n equals k, then it's definitely true for k plus 1. Well, it is true for n equals 1, so therefore it's true for n equals 2, and then n equals 3, and then so on, and so on, and so on. So yeah, quite a nice little question there. A nice little vectors question as well here. We've got this in Cartesian form, this line, and this in vector form. Let's put them both in vector form first. In fact, no. What I'm going to do is I'm just going to very quickly show you what this question means. Show L1 and L2 lie in the same plane. Now, what that's just saying to show you, or what they want you to show them, is that they intersect. That's all that means. Lying in the same plane just means that they intersect. And I thought I'd just very quickly show you why. Here are 3 lines that intersect at the same point. And what that means is that I can rotate the camera to make any 2 of them lie flat in the same plane. So now, right now, I've got this one and this one lying flat in the same plane. But likewise, I can rotate the camera to make these 2 in the same plane. There it is. There's a single plane that contains those 2. And likewise, which ones haven't I done? This one and this one and this one down here. Well, I can rotate the camera all the way around there to make those 2 lie in the same plane, right? And what I can't do is if I take a line that doesn't intersect, so this line looks like it does initially, but you turn the camera and you realize it doesn't, I can't make that lie in the same plane as any of the others, right? So lying in the same plane just means intersect. To be even more clear, these are the actual 2 lines that we've got, and I can of course just rotate the camera here, and we'll see that the plane that they both lie in, this is spoilers because this is the answer right here, but they both lie in this plane, right? That's how we can do it. So all we're looking for is for the lines to intersect. That's just this is just a super fancy way of saying show that these 2 lines intersect. Right. So okay, let's write this in vector form, which is going to be this with the signs changed plus lambda this, and then this in vector form. Of course, they've basically already given it, which is just this. Show that they intersect. Well, all I'm looking for is consistency between lambda and t. So the x coordinates are 1 plus 2 lambda, which I can set to be equal to 1 plus t, or 1 plus 1t, and then I can do the same for the y coordinates, and I can do the same for the z coordinates. And I just need to show that if I solve this simultaneous equation, I get the same 2 answers if I solve this simultaneous equation. So okay, if I call this equation 1, and I do equation 1 plus 2 lots of equation 2, these will cancel. This becomes a minus 1, this becomes a minus t, I believe, or sorry, 1 minus t, of course, which means t is 2. Put that back into here, you get lambda as 1. And then if you solve these 2 equations by doing, I think, 3 lots of this plus this, you're going to get this, which gives you t as 2, which gives you lambda as 1. And so because you've got consistency, they must intersect. You can even give them the point that they intersect by putting lambda as 1 into here and getting 3 minus 2, 7, I believe. Or putting t as 2 into here either, and you get the same answer. Okay, good. So we've shown that fairly conclusively. Find the vector equation for the plane. Now it's only a 1 marker, so you're not expected to do very much work here. all you can, I had the Cartesian form in GeoGebra just now, but that's far too much work. The vector form of the plane is just pick a point that you know works, so either of these two will be fine, and then add lambda amount of this direction vector and t amount of that one. And you can choose two different letters if you want to, but that's all you have to do. That is just pick a point. It doesn't matter whether you do this one or this one, and then just pick the two direction vectors, because these two lines almost span the plane, right? You can pick some amount of one line and then add some amount of the other one, and you can get to anywhere in the plane. Maybe I'll just very quickly demonstrate what I mean by that. So looking at this plane here, you can start at the point, really any point on the line. You could start at the intersection point if you wanted to. You could add some amount of this one, and then if you travel some amount of that one, you could span anywhere in the plane. If you added a certain amount of that and a certain amount of that, you could just get to any point on the plane eventually. You could of course add negative amounts to go backwards and get to other points, but that's kind of what they're asking you to do. Cool. Where are we? We did all this. Find the acute angle between L1 and L2. Well, this is just the dot product definition, isn't it? So you take the two direction vectors, nice easy 3 marks here. The magnitudes of the vectors, 1 squared plus 1 squared plus 2 squared is 6 rooted, 2 squared plus 1 squared plus 3 squared is 14 rooted, and then you just dot these. 1 times 2 is 2, plus 1, because 2 negatives, plus 6 makes this divided by this, and then just do inverse cos, and you get your answer of this many degrees roughly. Good, we're on the last question. It's another differential equation question. They like ending with questions of double derivatives, I think. It's actually not too bad as long as you know how there's some systems to remember here that aren't too bad. So show that this thing first. So we'll first differentiate this thing to get d2w by dt squared. So okay, well, we can differentiate that fairly easily. Remember, differentiating w with respect to 2 just gives you dw dt, and likewise s is just ds by dt. But of course, if I just double that, I literally then at this point, I substituted in ds by dt into here, which gave me that, and then I just shoved this into here and this into here, and then added 2w at the end. So I said the left hand side is 2 lots of all this, which I just worked out, minus 5 lots of this, plus this. Tempting to throw this into here as well, but you'll realize that that doesn't really end up going, or it becomes unnecessary, because if you notice, when you expand that out, you're going to get 5 dw dt, which will cancel straight away with that. So putting that in is unnecessary. Also, this minus 2w cancels with that one, which is nice, and we just end up with this, which is the right hand side. So that's nicely done. Find the general solution for the number of white-clawed tailfish. So I want to solve for w. Now, of course, we need to use this, don't we? So, okay, write the auxiliary equation. Pretend this is 0 for now. We'll deal with that later. Pretend this is just a quadratic with the auxiliary equation 2m squared minus 5m plus 2 equals 0. You solve for m, which is very easy to do. And now we've got 2 distinct real solutions. So you just need to remember which case that is, and it's this case here. You've got a e to the one root plus b e to the other root. That's the case we need to use. And now we also add in, so I think that's called the particular integral, is it? Or is it called the complementary function? I can't remember which is which. We need to add in this bit to make the entire thing. So, okay, if we've got it equal to that, the thing that we choose is omega equals k e to the minus t. So if you've got an e to the minus t there, you just put that there with a constant there. If it's a quadratic, you just put a quadratic with a bunch of constants in front. There's a table in the textbook. It's basically you just copy whatever you're looking at. Okay, so if we differentiate that, we get minus k e to the minus t, and if we differentiate again, we get plus again. And we can just shove these 3 things into here, across here, and we get this. This minus and this minus cancel, which equals that, of course. But now, of course, we can just say 2k plus 5k plus 2k is 9k, divide by 9 and cancel these, and we get k as 50. And so the extra bit we need to add on to this is 50 e to the minus t. And that's our general solution for w. Then it asks us for the number of signal crayfish, which is s, essentially. So, okay, well, there's a couple of ways to do this, but probably the easiest way is to go into this equation, shove this w into there, differentiate this and shove it into there, and we should be able to solve for f's. So if I differentiate this, just this 0.5 gets brought down, this 2 gets brought down, this minus gets brought down, shove that into there, and shove this into there, and we end up with, or rearrange it, I guess, first if you want to. And we get this, expand out and rearrange, or collect together, I should say, rather than rearrange, and we end up with this this solution for s. The model predicts at time t that the population of white-cored crayfish will have died out. So we're looking for w to be 0 and solving for t. Now first we need to use these conditions. So if w is 65 when t is 0, now when t is 0, this becomes 1, this becomes 1, this becomes 1. So we get 65 is equal to a plus b plus 50, which of course means a plus b is 15. And we can do the same thing for this equation here. 85 is it going to be equal to 0.8a plus 0.2b plus 70, and we can get this, and this is just a simultaneous equation. I think I times this one by 5, and then did this one to take away this one. I did, and got a is 20, which gave me b is clearly from here minus 5. So that gives me my two solutions in w and s with actual numbers in here, which is good. And now I'm looking for w to be 0. So I'm going to put 0 into here, and then I'm going to try and solve this equation, which isn't trivial. But because of all these e's, and they don't cancel nicely, what I noticed is if I times all of this by e to the t, I get this. Just e to the t adds on, this obviously cancels, add 1 to there, add 1 to there. And then actually this is a quadratic. It's very well hidden because it was even better hidden here. But if I substitute, say, f equals e to the 1.5t, square that, you get e to the 3t, and this becomes 20f minus 5f squared. Which you can of course rearrange and divide and so on, and you end up with something that solves. You can obviously put in that calculator, and of course that means e to the 1.5t is this, which you can then do. Now e to the 1.5t can't be negative, and 2 minus root 14 is negative, so it's going to have the plus 1. Take log of that, I put it as a decimal at this point, put log of that, then divide by 1.5, and you should have your t value. To 3 decimal places is this. Suggest a limitation of the model. Well, this is the time when the white crayfish is 0. Now, the model is just going to continue. You had some larger amount of crayfish to start with, white ones. They're now 0 here, and the model doesn't stop. So the amount of crayfish will now become, white crayfish will now become negative after this, which is clearly not something that can happen. So that will be a limitation there. Okay, thank you so much for watching. Apologies for my voice and general demeanor in this video, but I thought better to use my time productively doing something than nothing, so